Now we're going to do subtraction of fractions using more complicated numbers. If you haven't seen the first video, make sure you take a look at the first one before you look at this one, because I'm going to be making reference to things we covered in the first one, okay? Starting with number one. Number one, we again have a subtraction. We have a mixed number and a whole number. Sometimes these get tricky because I don't know if I can do the subtraction or not. So what I like to do, and this is a good policy to do if you're not too comfortable with this math, is let's turn this this number 8 that's by itself into a mixed number. So I'm going to keep the same denominator of 16, but now, because I don't have any, I'm going to turn that into 0 over 16. Now I can ask my questions. Can I subtract 1 from 8? Yes, I can. Can I subtract 7 from 0? No, I can't. And see, if you notice, that's the key. If you cannot do part of the subtraction because you can do it with one but not the other, that's when we know we need to do this step I'm about to show you. This 8 here, we're going to take 1 away from the 8, and it's going to become a 7. So this we're borrowing like in any type of subtraction. Because I'm borrowing 1 from 8, now this becomes a 7, and I'm going to use that number that I took away as a 16 over 16. Now the reason why I'm using a 16 over 16 is for two reasons. One, anytime you have a number over the same number, that always signifies 1, which is the one we took away from the 8. Also, I want to use 16 over 16 because my common number in denominators is 16 from the other fraction. Because I don't want to have to go looking for a common denominator, I go ahead and use the same denominator that it was given to me in the original expression. Now we go ahead and do the rest of my fractions, 1 and 7 over 16, and we ask the question again. Can I subtract 1 from 7? Yes, I can. Can I subtract 7 from 16? Yes, I can. Now I can go ahead and subtract. 7 minus 1 equals 6. 16 minus 7 is going to give me 9 over 16. 9 and 16, even though they look like they have a common number, there is no common number between 9 and 16. So this is my final answer, 6 and 9/16. Let's do another one that's similar to this one. Again, we start off with a whole number minus 2 3/4. In order to make my comparison, I turn this into a mixed fraction by putting 0 over 4/4. Remember, this is quarters, so I use the same number as here. I once again ask my question, can I subtract 2 from 6? Yes, I can. Can I subtract 3 from 0? No, I cannot. And this is the concept of borrowing. Let me show you another example of this for those of you that are still not too comfortable with this. When we do a subtraction, let's say, for example, we do 32 minus, let's say, a 17. What do we do in this type of operation? Well, if you notice, I can't do 2 minus 7. So what do we normally do? We turn this 3 into a 2. In other words, we borrow 1 from the one next to it, and that becomes a 12. I do my subtraction. 12 minus 7 is 5. 2 minus 1 is 1. So if you notice, the borrowing is a concept we do all the time in math. It's just in a different context. So now we're borrowing instead of the number next to it, because we don't have a number, we borrow from the whole number. The 6 now is going to become, just like this 3 became a 2, this 6 is going to become a 5. I'm going to add the part that I took away from the 6, which is going to be 4/4. Because I have no fourths, I don't need to combine that with this. 2 3/4. Now, can I subtract 2 from 5? Yes, we can. Can I subtract 3 from 4? Yes, we can. So we do our math. 5 minus 2 equals 3. 4 minus 3 equals 1 over 4. I cannot reduce. This is my final answer. It's important to understand when you need to borrow and when you're not supposed to borrow. And that's where example number 3 comes into play. Same thing, I have a mixed fraction and a whole number. Now notice that the whole number that's by itself is in the second position, not in the first one like in the first two examples. However, we can still do the 0 over the denominator to help us see this. So I'm going to use the denominator of 3. So that 4 becomes 4 and 0 over 3. We do our question. Can 4 be subtracted from 7? Yes, it can. Can 0 be subtracted from 2? Yes, it can. So in this one, we don't need to borrow, even though we have a whole number like we did on the first two. So on this one, we do our math. 7 minus 4 equals 3. 2 minus 0 equals 2. Over 3, I cannot reduce. This is my final answer. So that's why it's important to know the difference, because these are a lot easier than these. But you need to know when to borrow and when not to borrow. If you borrowed here, then you would end up with a wrong answer. Let's move on to